And what I will do now is that I will ask each of the panelists to introduce themselves very quickly. So I will stop sharing my screen. Then maybe Jean-Claude, Nicolas, Jasmin, Francois, Christian, you can put your video on. And let's start with Jean-Claude. So each of you have 1 minute to tell us who you are, who you work, what organization you work for, and what you will tell us today. Jean-Claude?
Yes, good morning, everybody. So I'm Jean-Claude Belfiore, and I joined Huawei at the end of 2015. Before joining Huawei, I was a professor at Telecom Paris, where I was working on wireless communications and essentially coding, error correction coding for wireless communications. Then I joined Huawei, where I worked on 5G first, and I participated to the standardization of 5G, essentially for error correcting codes and more general wireless problems as well. And now I'm leading a group inside Huawei in the, at least in research. So this group is doing advanced research for beyond 5G. And we have a big aspect there, which is artificial intelligence, because we guess that beyond 5G will be essential, not only, but the essentially communications between intelligent machines. Thank you.
Thanks. Thank you very much. Jasmin?
Yes, hey, my name is Jasmin Grosinger. Do you want me to use my slides now that I've prepared?
No, just introduce yourself.
Just a few words. I see, okay. So I'm Jasmin Grosinger, and I'm working at the Orebro University, which is in Sweden, just in the 2 hours by train in the west of Stockholm. And I did my PhD here at the Orebro University at the lab that is called AASS. And mostly in our lab, we deal with AI and robotics together. And I did my PhD quite recently. I stopped in 2019 in December. And after that, I was further employed as a researcher at Orebro University, and I am now working in the project which is called AI for EU.
Thank you, Jasmin. Nicolas?
Hi, my name's Nicholas Asher. I'm a director of research at the CNRS, the Center for National Scientific Research of France. I'm also the scientific director of Toulouse's Interdisciplinary AI Institute, Aniti. I came to the CNRS in 2006. Before that, I was director of a department in the University of Texas at Austin. I've worked a lot on natural language, both modeling using logic and now statistical and machine learning means. That's made me think very hard about some of the foundational issues in AI that we'll be talking about today, and I'll be advocating a hybrid approach. I'll try and tell you what that's about. I should also say that my home lab in Toulouse is the Institut de Recherche en Informatique de Toulouse, or IRIT. Okay, and just one other thing, Aniti's, well, I'll say a little bit more about Aniti in just a minute, but we have as our goal to bring AI applications into the sectors of mobility and Industry 4.0, especially where critical systems are an issue where lives are potentially at stake.
Thanks. Christian?
So hello, good morning. I'm Christian. I'm with the German Research Center for Artificial Intelligence. I'm a principal researcher there for like forever, 20 years now in artificial intelligence, and I'm the head of the Competence Center for Autonomous Driving. But quite recently, I'm also responsible for the endeavors in explainable AI and coordinating this both internally and also with the external collaborations. So the Trustworthy AI initiatives and the autonomous driving initiatives go well together. And that's why Gail already presented a few of these outlines in this direction. But that's my job at DFKI, and of course we also publish papers on specific solutions for that. But I go deeper in a second.
Thank you. And Francois?
Hello, everybody. Good morning. So I am Francois Terrier. I am from CEA. I am responsible of the AI program at the CEA level. Previously, I was head of a department for software and system engineering, where we have push the development and the industrial partnerships around two main open source platforms. One is on Eclipse called Papyrus. One other is independent from Eclipse called Pharmacy, and it's two technology that will also help us for AI program with a lot of other technologies. Thank you.
Thanks. So let's start with the presentation from Jean-Claude. Jean-Claude, I let you share your screen, and maybe all of us, the rest of us, we just go on mute and oh, sorry, we just stop our videos.
Can you see my screen?
Yes, we can see your screen.
Okay, thank you.
I think you are good to go.
Okay. Okay, thank you. So what I want to present you is something that is not really common in what is called explainable AI or trustworthy AI now, but it is direction that we in Huawei want to follow and to see exactly where it can go. And the first results that we are currently that we're getting currently are very encouraging. So that's why I think it's a good direction. So the idea is to see, in fact, if we want, what does it mean explaining AI? It means that we need to understand what, for example, what a neural network is doing exactly. So that means that the neural network has to speak a language that we are able to understand. And we can start with some very simple language, which is just some type logic, and to see what kind of semantics the neural networks, and you will see it's very simple neural networks can see, can tell us in simple experience to start with. Okay, so and this is what we aim at doing. So perceptual AI, for now, I mean, I call it perceptual AI because it's much closer to our notion of perception, to our notion of understanding, thinking, etc. So it's really the level, the very low levels of intelligence. And it only solves a global problem, and it will not be enough in the future. And so we aim at exploring how these machines can acquire human-like communication and reasoning capabilities. As I told you, I'm coming from the communication community. And so we want exactly to know what kind of information, of semantic information, the machines will be able to exchange during a communication. And that's why we need to understand how these machines can acquire human-like communication reasoning capabilities. And so that they can, of course, be able to invent, to recognize new situation environments, not just using let's say, the statistical properties of the features that they are trying to understand. Okay, so let's say that once again, I'm coming from the communication community. And so the big theoretical thing in communication is the information theory of Claude Elwood-Shannon. But there is something else that not so many people know, which is something appearing here in an article of Weaver and Shannon. It's a small book, in fact, and in which they exactly say these things, that there are three levels of communication. The level A, how accurately can the symbols of communication be transmitted, is what they call the technical problem. And it is, in fact, what has been applied up to now to all our communication problems. But then there are two other levels, level B and level C, which have not been explored so much. Almost nothing very, let's say, nothing that has been agreed by most people come from these two other levels. So level B, it's related to the semantic problem. And so it is at the transmitting side, which kind, I mean, how do the transmitted symbols convey the design meaning? Level C, it's moreover at the receiving side, what can a machine do with what has been transmitted? So can it enjoy what has been transmitted, and in which way? And the problem is how to encode this semantic, how to represent it, what is it? And so there's been some attempt last year, for example, to propose what is called the semantic plane besides data and control in future communication beyond 5G communication. So I will not do anything about that. And so the problem, and this is very, very related to how, so because if we know what a machine, an intelligent machine can understand from another intelligent machine, so probably if we go in the middle, let's say, we will be able to understand also what the machine is doing. And so, because we are also a kind of intelligent machine, of course. And one key point is the notion of composition, and which is in fact common to any kind of language, right? And we need, of course, for that to introduce syntax and semantic. So in our case, the syntax will be exactly some logical language, and for the semantic, we will see. So let's say that, so it's a very short overview and of course, very oriented. And so these are some figures of linguistic, essentially, because these notions of understanding, of meaning, of semantic, and are, let's say, coming essentially from the principle of semantic compositionality, which states that the meaning of a complex expression is determined by the meanings of its constituent expressions, the rules used to combine them, and also of the context. Of course, there are many things to say about that. It's not something which is maybe commonly accepted by everybody, but it's at least a basis that we can use, especially because the tasks that we want some intelligent machine to do are enough simple for now, so that this principle of semantic compositionality can be widely accepted. All right. So, oops, sorry. So for this, in order to understand if this principle of compositionality, of semantic compositionality, is not just reserved to language, but if it can be generalizable to any kind of knowledge, because in fact, the machines that we have up to now, they don't just do, for example, natural language processing. They're doing many, many different things, from image processing to graph processing, etc. So, and that's why we need some mathematical formulation. And it is basically based on the notion of space. So, but it's a general notion of space. I don't want to go into details on this kind of notion. You have to know that this notion of space, which is heavily related to notions of geometry, topology, is not only the notion of space that all of us have, let's say, known in our high school or even superior studies, university studies. It's much, much more than that. It can be very general, coming from Henri Poincaré, to the studies of the 20th century with homology, cohomology, and to vast generalizations coming from Alexander Grothendieck. So I don't want to go into details on that, but it is exactly, we have used these notions of space to understand the interactions that can be between, let's say, the topologies or geometries that you can find in what the neural networks are doing, for example, and the logic and the semantic that can be extracted from them. Okay. So it is very important also to say that on one side, we have these notions of topologies, geometries, and there is this connection coming from this general notion of spaces, especially from Alexander Grothendieck. And this connection is between this the topology, geometry, and on the other hand, the logic and the theories, etc. And so, in fact, what we need for these theories and to establish, in fact, how this notion of logic, language, etc., can be related to, for example, what the tasks that neural networks, for example, are doing now. We need, in fact, to establish this connection between propositions on one hand and judgment on the other hand. So propositions that are coming from language and this judgment that will establish this notion of semantics. And by using, in our case, combinations of logical operations, so true, implication, let's say the and connective, or the conjunction, disjunction, and all these symbols that come from a predicate calculus. And then we have to establish all these propositions, these formulas, if they are true, not true, or maybe true, you know, all these kinds of. And then you have also all these deductions. And so what we state, and this is how we can, what is important about what we are doing now, is that, in fact, classical neural networks are able to establish these propositions, to deduce, etc. And I will show you this in a simple experiment. And this experiment, so we have done a series, in fact, 3 series of experiments. So I will tell you some details on the first experiment because it's quite easy to understand. For the other ones, it requires too much time, and so I don't have this today. So this first experiment that will show you the apparition of propositional calculus, so Boolean logic appearing in neural networks. It has been inspired by neurosciences, and especially these 2 guys, Miliotis and Moshovakis. So in 2017, they have studied the specific neurons. So these are natural neurons in the premotor cortex of monkeys. And in fact, they have established that the outputs of MEC cells, so which are cells, so cells, it means neurons, in fact, they are movement equivalent cells, and they are firing during the preparation and execution of directed movements of the eye and of the arm, and without preference for the conditions, eye alone, arm alone, on both, eye and arm together. But they have preference for goal in space and depending on each condition. And so, let's say, inspired by these experiments that have been done on monkeys, we have tried to do it using just artificial neurons. So very classical artificial neural networks using for training backpropagation, you know, based on gradient descent, some very classical things, and on a very, very small neural networks. And this is, for example, what we have seen. So these two graphs, these two plots, in fact, are just, so you can see the angles here. So these angles are the preference angles. They are equivalent to what monkeys are doing in the neuroscience experiment. And in blue, you will see that it is a preference for the eye. So that means it is as if the monkeys were using the eye in the right direction in order so this is the eye which has been chosen by these MEC cells. In red, it is the hand, and in the green, it's eye plus hand. So, for example, in the first cell, in the first neuron of some hidden layer, so we can see that on the blue curve, so the eye curve, so we can see that eye implies +1 because the full line means that so the neuron saturates at +1 because I forgot to say that the activation function is a hyperbolic tangent. And the dotted lines means that it saturates at -1. Okay. So you can see that I implies +1. So that means that whatever the angle can be, it's always a +1. Hand saturates at -1 because it's always a dotted lines, whatever the angle can be. And for eye plus hand, we cannot say anything because it depends on the angle. And on the other cell, we can say the same kind of thing, that eye in blue implies +1, eye and hand in green implies +1, and in red, we cannot say anything about the hand because we can have both. If we contrapose these propositions, we have, for the first one, -1 implies eye or eye plus hand. That means that this cell is able to say that if it saturates at -1, it can be either hand or eye plus hand. It means that it's a Boolean type of reasoning. It's a Boolean algebra that is used by this neural cell. So it means that it can be considered as a logical cell. And the same for, let's say, the other proposition of the first cell. +1 implies either eye or eye plus hand. If we compose, then this cell with the other one, in which -1 implies hand by contraposition, then we can, for example, if we have a -1 in both cells, we can say that -1 implies hand. And if we have a +1 and in the first cell and -1 in the second one, then we have some contradiction. Okay, we have been able to say something equivalent by using another kind of experiment in which predicate calculus could have been implemented in hidden cells, in hidden layers of some other simple neural networks. And that means that we can derive proposition with the quantifiers for all, and it exists. And we have also highlighted capability of inventions by connecting one network to another pre-trained one through a third one, which is playing the role of an interpreter. So in this case, all the neurons of the interpreter were logical neurons. So it's something that is very, very new, very important, that say that neural networks, I mean, regular neural networks can, in fact, exhibit some Boolean propositional calculus, also predicate calculus, also some kind of invention, so some kind of pre-thinking, let's say. And it is something that we're able to understand, we human beings. So this is what I wanted to tell you. Thank you very much.
Thank you very much, Jean-Claude. Very, very interesting. So the next presentation will be from Jasmin, and then we will have more time for questions at the end. I see that Boris sent us the first question, so I suggest we keep it for the end. So Jasmin, if you want to if you can share your screen, your presentation. Yeah, we see it.
Great.
We hear you. You can put your video on if you want, and
Yes.
And you're good to go.
Okay, so I will only take 2 or 3 minutes to say where I come from. And yeah, so as you know already, my name is Jasmin Grosinger, and I'm part of the AI for EU project. I just want to say that the few slides that I'm showing here now is not the official position of AI for EU. It's just I am working for AI for EU, and this is my view. So let's go on. So AI for EU is about a so-called AI on-demand platform, and so how did it all start? It all started in 2018 with a European Commission call, because the European Commission realized, well, if we want to keep up within the field of AI in Europe, then we have to put some money, research money into it. So, and the point was to create the central access point of AI. And that is what is called the AI on-demand platform. And the answer to this call was the project that is now going on and running. And this is AI for EU, which is from 2019 to 2021. And yeah, the main goal of this, there are many work packages, but the main goal is to build this AI European platform. And it's not only meant to exist, this platform, only for these few years of the AI for EU project, but it's meant to continue. And it's actually mentioned in also several following calls within the horizon of Europe. So the AI on-demand platform is here to stay, in short. This is the link if you want to visit this AI on-demand platform. It's already online, but I want to say that it's still developed, so it's continuously developing more features. But in a nutshell, what it is you could sum it up, you can see it as a kind of a social platform. So it's many people and organizations within AI that are registered. So on the one hand, you can go and get expertise, but then there are also discussion groups and different web cafes that are organized and so on. On the other hand, it's also a repository of different AI assets, and these could be different tools, but also data sets and so on. And as a third point, you can see the platform as an experiment place where you can build and run AI systems. And what it has to do with this workshop today is, well, there are several steps. The goal of the AI for the AI platform on demand is to create AI and to bring together AI researchers in Europe. And this AI made in Europe is supposed to be what is called human-centric. And by human-centric, you mean that it's an AI that should follow trustworthiness. And what is trustworthy AI? Well, there is a recent ethics guidelines that has been published also by the European Commission within a high-level expert group on artificial intelligence that defines some ethic guidelines for trustworthy AI. And to achieve those guidelines, they name different principles and 7 key requirements. And within AI for EU, what we are doing is, well, now we have these theoretic ethic guidelines by the EU, but what does it mean for if you want to build systems? How can you put this into technology concretely? And the way AI for EU approaches this challenge is to say that for human-centered AI, you can split different approaches in the different topics of AI and in 5 different topics, and that is explainable AI, verifiable AI, collaborative AI, integrative and physical AI. Of course, all these topics, they are not isolated, and there are many systems you could put in several of these categories. Here on the left, you can see the 7 key requirements of the ethics guidelines by the European Commission, and how these different dimensions of AI relate to these key requirements. Yeah, but we can also discuss this in detail later, I would say. And the AI platform and open source, well, that's a topic that is twofold, because on the one hand, as I mentioned, it's the AI platform is a repository of assets. So far, there are 61 that have been published on the platform, but it's a number that is growing. And many of those assets are actually published as open source or under a GNU license. And the assets that are published, it's a decentralized user-based evaluation. So it's not some central organization saying this is a good or how good or bad is this asset. And then the second part of this topic is that also the AI platform, and now I see, Gail, I also have a typo here. So the AI platform also is now currently in the process of towards being an open source as well. Because, as I said, right now AI for EU is responsible for developing this platform, but it will and is supposed to exist in the future as well, and is here to stay. And in fact, there are several different future EU research calls that rely on the platform existing and that aim to extend it and to enrich it. And at the moment, in fact, it's also under discussion to put the AI on demand platform as an open source development under Eclipse. So thank you for your attention. And as I mentioned, it's not the official position of AI for EU. I'm just one of those people working in AI for EU and know some things about it. Yes. Thank you.
Thanks, Jasmin. Yeah, maybe you stop. Yes. And okay, Nicolas, I suggest you go next.
Okay.
So you can share your screen and tell us more about the point of view of Aniti.
Okay. Well, good
You're
morning.
good to go.
Thank you. This is about Aniti and how we take our take on trustworthy AI. So what is Aniti? Well, it's a interdisciplinary institute for AI. These are network centers for research, education, economic development with a high international visibility in France. The initial call was published on 25th of July in 2018. There were 4 sites pre-selected, and then we all submitted detailed projects, and we had a hearing with the international jury. And the decision was on April 26, 2019. And so we're a network center of 4 of these centers with a 4-year duration that is eventually renewable. Each one of these centers or institutes has a particular applicative mission. For example, Nice and Grenoble and Paris are all deeply involved in health issues. Paris has many other areas of application. In Toulouse, we are concentrating our efforts in AI on the applicative sectors of mobility. And so I'm looking very much forward to hearing from Christian, because I think he also is very much involved in that. And also in industrial processes. We have about 200 researchers and students in the Institute, and these application areas mean that we really have to worry about trustworthy AI in several aspects. So when I'm talking about intelligent mobility, I'm thinking about things like single pilot operations for large aircraft, like the Airbus 350, eventually. And what that means is that the Airbus will be flying with a single pilot and will need the assistance of a virtual co-pilot that must be able to also communicate with the ground, air traffic control, and land and do all the necessary things to keep the plane safe in the event that the pilot is incapacitated for one reason or another. So what does that mean? How can we ensure our industrial partners like Airbus that people are going to fly in such an airplane? Mm-hmm. Okay, so we need that if there's an AI system that's an intelligent AI co-pilot, we need, as Jean-Claude was saying, to be able to explain, or that system has to be able to explain its behavior and its predictions. Yeah, otherwise, the pilot won't have confidence in it, nor will the airplane passengers, and so people won't buy tickets on that airplane, and it'll be a big failure. There's also a problem, a more technical problem that's very important, I think, for trustworthy AI that we're very interested in. Many people are, and it has to do with robustness. And robustness, roughly, is the following problem. If you change, you have some input data, the machine makes a certain prediction. Suppose you change that data a little bit, such that it doesn't matter for humans to make, for human decision making. That is, humans with the slightly changed data will make the same prediction. Do we want the machine to do that? In many cases, yes. And in many cases of very high performance deep neural net machine learning systems, the answer is that we don't have that property. And there's actually a mathematical problem there that I'll just explain very briefly and tell you about how we are thinking about going about dealing with it. Finally, there is a huge question about how AI is going to be used, and that was brought up in the previous talk, when AI is going to be acceptable by the general public. That is, how can we ensure that our AI algorithms, when they're used by various industries, are going to rely on fair and representative data? Why is this a problem? In statistics, for over 200 years, there's been a worry about getting a representative data sample to generalize from. But nowadays, when we use high-performance AI systems, we are often making use of extremely large databases, like in my field, in natural language processing, we're often using databases that are scraped from the web. They're so big, nobody in their lifetime will be able to look at all the data in that database, and even whole teams won't be able to. Nevertheless, we're using that database to inform a neural net that will make statistical generalizations and make certain predictions from that data. And we don't know whether that data is distributed in the right way, or whether it's fair. Does it contain biases that we don't want to have in there? And if the public is going to accept AI in everyday industrial settings, they'll want to be able to know, we believe, that the algorithms are fair, they're not introducing biases on their own, and that they're starting from fair data. And we already have many examples in industry and in various applications where we know that we don't have fair data. Okay. So let me go first and touch base a little bit with what Jean-Claude was talking about interpretable and explainable AI from the perspective of Aniti. I want to distinguish between two things which I think are important. One is, we want to explain very often the behavior and the predictions of an AI or an ML system, and that is distinct from explaining the phenomena in the data that the ML system is supposed to capture, okay? So sometimes we don't have an antecedent model of what we're trying to capture with machine learning. And we're actually using machine learning to build a model, a probabilistic model. Then we can be asked, why did this particular phenomenon that we're seeing in the data happen? And maybe the machine learned model can help us provide such an explanation. But there's the other notion of explainability, which I think is somehow more pressing, at least for my co-pilot example, is we need to explain why the machine learning model made the prediction it did. And that means, I agree with Jean-Claude, that we have to think of the machine learning model in a particular way. So we have to think about it as a mathematical or as a logical object. And as I come from studies in NLP, I naturally gravitate to the tradition to which Jean-Claude alluded to, especially Montague. Less so type theory for our purposes here, and I'll try and explain why from our perspective. But certainly logic, we can think of machine learning models as logical objects. How do we do that? Well, we can actually translate the entire learned system into a series of clauses in a logical language. Typically, we're taking propositional logic or fragments of predicate logic. Now that means even for a rather simple machine learning model, that translation gets pretty complicated, pretty big. And so we are trying to use languages that are tractable and for which we have good solvers. Because roughly the way we think of an explanation then is we have a prediction and we will find the minimally sufficient set of clauses in the machine learned model that entail that prediction. And that will be an explanation. It will also be an explanation that is valid because it's supported by logical consequence. and that makes it quite different from many of the heuristic explanation tools that are currently being used, like LIME or SHAP. Now, the reason why we have to keep our language simple is because when we translate the machine learning model into logic, as I said, we have many clauses. And it's only recently that in automated reasoning for the last 10 years that we've been able to start solving problems of satisfiability and unsatisfiability for very large sets of clauses, say hundreds of thousands of clauses. And so that means that we can do that now, and so we can actually produce automatically valid explanations for the behavior of a machine learning model that's not too complex. The big problem here is how can we scale up from these relatively simple machine learning models? We believe that here, finally, we have to do something. We have to balance our logical approach with a more statistical approach, various types of statistical sampling that will enable us to get something, an approach that scales up to give explanations of sophisticated machine learning models. And that's what we call a hybrid kind of approach to AI. And once again, that was brought up in the talk on AI for AU on integrating various methods, AI methods, and we think that's very important. Okay, let me talk briefly about robust AI. What's the problem here? There's a mathematical fact, sometimes known as the curse of dimensionality, which goes as follows. We're getting finer and finer predictions of, or finer and finer encodings of data. We are now, because of our computational resources, we can encode data over hundreds of thousands, even maybe millions of dimensions. So if you think about encoding an image, you know, that's a very complicated thing. If your image has 2,000 pixels and each pixel can have 130 shades of gray, well, you can now calculate just how many inputs you can have to code the entire picture. Now, what happens is that if you have a finite volume of data, but you're describing it in higher and higher dimensions, what happens is that the probability of picking an arbitrary point in that data is, as it's being near or on the surface, within a radius alpha of the surface, becomes very high as the set of dimensions gets larger and larger. What does that mean about this surface that I'm talking about? Well, the surface is a boundary, let's say, between the prediction of something's being A and a not A. So as you get more and more dimensions, there's less and less room, wiggle room, let's say, for the prediction to make. And now you've seen this kind of, you've seen the kind of effect of this with the very sophisticated image recognition machine learning systems that are now available. You could take a picture of an ostrich, you could put a slight mask, and the machine will recognize that it's an ostrich very quickly and very accurately. Now you put a slight mask on the picture, that is, you perturb a few pixels. Humans don't notice that, and the machine all of a sudden says it's a gun. And so the prediction is wildly off. That's a very unrobust system. And it's part of it is because we're describing the data so finely. So what can we do to this? Well, we can make a trade-off here between maybe get more robustness but less precision. That's one thing that we look at for AI in critical systems. We're also looking at how robustness is, how it arises. It can arise from sensitivity to the input, from the training set, with resistance to outliers, or with respect to distributive shift. There's also different kinds of robustness. So right now, what I was talking about is point-wise robustness. That is, given a particular data point, how robust is the prediction that I'm making about that data point within a radius around that data point. But what we can do instead, and here I'm going to also make a link with Grothendieck, is to think about not point-wise robustness, but think about more about regions in the data where we have high confidence, and describe those, and to try and make sense of those high confidence regions in mathematical terms. We also want to look at how we do optimization in our machine learning systems and find out when those methods are guaranteed to work and when they aren't. There's still a lot that we don't know about these things. But one thing that is sort of a specialty in Toulouse is to concentrate on semi-algebraic representations, which actually have a very tight connection to what Grothendieck called la topologie modérée. It's where mathematics makes sense and you don't have monsters like Cantor sets, which have an uncountable number of points but zero measure. These kinds of things screw up many of the methods that many of the tools that we need to ensure robustness. And the way we're looking at robustness we look at counterfactual models. We're also looking at algebraic approaches, and as I mentioned, these links to optimization algorithms. Finally, about fair AI. So we are very heavily invested in detecting biases and eliminating them. I have to say that detecting biases is very difficult. And that's for us, at least right now, an unsolved problem, an open problem. We can do it in certain cases. In a lot of cases, we're not sure what we're looking for. And if the person that, or system that has the bias is maybe not cooperative, but antagonistic, I'll give you an example we can't find them. So an example is a bank is using an algorithm to determine whether I get a loan or not. I don't get the loan, I want to know why. And so I'm asking for an explanation. And so this talk about fairness has lots of links with the first topic that I talked about. The bank may not want to reveal what criteria it's using to make the prediction. And there may be many criteria. The issue may be overdetermined. So it may give one explanation that has the ring of truth to it, but there's another explanation that's actually where the premises are actually being used by the machine, and those are biased. So the bank might say, well, if you'd earned 100,000 euros, Nicholas, instead of 50,000, we'd have given you the loan. But what they aren't telling me, that's perhaps true, but what they're telling me is, well, even if I had 50,000 euros, but I weren't black, if I were white, I would have gotten the loan. And so there's an imbalance in there. And if the bank is clever, and we're poking at the algorithm, we have results to show that we may never be able to find the unfair bias except using exponential time, which is unpractical. We're also interested in the ethical, legal, and epistemological consequences of biases. So some biases are ethically bad, some biases are illegal, and we need to be able to detect them. Some biases are epistemological, that is, they help learning or they make it impossible, and so we're interested in those. And we found that hybrid approaches to bias, where we're using both constraints and statistical operations on the data, are very helpful. In particular, we're using transport theory, optimal transport theory, to clean a database from a suspected bias. That what we do is we can eliminate the bias, but perturb the data minimally so that there's a minimal loss of information. And that's a kind of tool that we think is very useful, not only for our industrial partners, but I think for the AI community at large and the EU effort into making AI trustable and transparent. So, and that's a sort of short introduction to the kinds of issues we're dealing with in Aniti.
Thank you very much, Nicolas. That's very interesting.
Arrêtez.
Christian?
I'm here.
Yes.
Can you hear me?
Share something or?
Yes.
So, what's that?
No, I said we can hear you.
Do you want to share some slides?
Sure. Let me just ask a question. The presentations before me have been, say, way longer than 10 minutes. You told me earlier.
I think that's, well, that's, if we can stick to 10 minutes, that's wonderful.
Yeah, I was
12, I will not stop you because I didn't stop the previous.
Yeah, but I want to just ask whether I should stick with what you said or stick with what the others did. So that's the decision I have to take here. So
take 12 to 15 minutes max.
All right. So I will make up some time here because yeah. So can you see my slides?
Yeah, we can see your slides.
Okay. Do you mind me staying in this like presenters mode? It makes my life more comfortable.
We can do that.
Okay. So yeah, it's about trustworthy AI, and as I said, we are working in autonomous driving here, and I will focus also on autonomous driving in this talk. So earlier, I was once asked the question to define AI safety in autonomous driving for those AI components, and I said something like a condition where the threat of life or health of humans is that is introduced by AI, right? Is reduced, believably reduced to an agreed upon level. That's very general, and I want to share with you a few thoughts on what this actually means. So introduced by the AI components. So you know, a few years back, NVIDIA claimed that we just need one large deep neural net between sensors and wheels, and that's going to be enough for highly autonomous, highly automated driving. But meanwhile, I think this modular architecture is or the end-to-end learning is off the table, and we're talking about a modular architecture. That is one of the things that I would like to highlight. Then this diagnosability, you know, explainability in the automotive context is often referred in the flavor of diagnosability. That's why I call it like that. So it actually means what we all talk about: explainable AI and avoidance of black boxes and how we can deal with that. And then if you look into these industry applications and in the industry itself, you find explainable and understandability of this also has something to do with the competencies and the rights to look into things. And maybe this is connected to Gael's talk with the traceability and the institution that has some sort of trusted control. We'll get back to that in a second. What does believably reduced mean in this context? So we have in highly automated driving, in autonomous driving, we deal with various kinds of testing, and the automotive industry usually has a vast attitude towards this on-road testing. You have to you know, drive so and so many millions of miles to be safe. But you know, meanwhile, we know that this is not going to be enough, because the things that we look at, the rare cases, we will not really find. Also, some of the cases, like this famous child runs in front of car situation, we don't even want to collect data on road, and therefore the virtual testing and testing in so-called synthetic data environments is one of the key components here. Maybe also true in aviation. Not so sure about that. We can talk. But then we need to have validation sets that cover a sufficient sufficient number of those critical scenarios, and Huawei, others are also involved in SOTIF, the safety of the intended functionality standardization, which is a scenario-based standardization approach that deals with critical cases, corner case testing, and so forth. But even then, you will have to deal with the unknown unsafe. That means in AI and in these real life cases in aviation as well as in automotive, you can never be sure that you have covered everything, or put it in other words, you can be sure that you didn't cover everything. So and if you follow this SAE standard, this level of automation standard, they talk about these minimal risk maneuvers. So once the vehicle has encountered a situation that it cannot handle, it should trigger a minimal risk maneuver, which is fine when the maneuver is defined well. But the problem in AI is to know when it is uncertain. You know, it's not about it's a robustness, yes, but also to have an idea of how well is my my perception, or am I certain or uncertain? That is something that AI had for decades, but with deep learning, it was largely forgotten for a while, and now it comes back with the Bayesian deep learning initiatives, etc. But you know, I think this uncertainty handling is one of the most important aspects for the trustworthy AI that I would like to bring on the table. I have here an overview. I hope you can still see it. It's in German, but I will walk you through. So it says, at the top level note says requirements for AI for highly automated driving, and then you have these the top level requirements. That is the handling of uncertainty, that is transparency and explainability, and this the modularization. And underneath, we identified robustness, but I think my notion of robustness is a little bit more general than we had in the previous talk, because it covers also you know, accuracy and these kind of things. So robustness in the wider sense, accountability, so that we can trace back errors, etc., etc. And then we can link this to the various departments of legal processing. In German, it's Zulassungsrecht. That means registration law, and then also liability law and data protection law. I want to share from what we do at DFKI, because this talk can only scratch the surface, of course. Well, first of all, nobody else has showed this before, but again, to remind everybody, artificial intelligence is not only deep neural nets. It's not even neural nets. It's not even only machine learning, but it has this very important symbolic part that helps a lot when it comes to making things more explainable. And in our projects, we actually use that. This slide is, I think for you, it's a no-brainer, but this explains again that the validation requirements are not only trying to balance the data, and they're not only trying to find the appropriate model, but it must be the combination of all these, and also the process of creating AI must be valid. So again, links to Gael's very first presentation when he said that we need to have these trusted processes and we need to have the right KPIs to understand it. And because, you know, a few years back, I was part of the ISO standardization committee in Beijing, and they were talking about how to unbias the data, but you know, unbiasing data alone doesn't help us here. What are we doing at DFKI, and especially in our department? We do this. So we try to use AI to confirm compliance for AI. That sounds weird, but it's actually not. We working on learning how to assure compliance in this framework of synthetic data generation, and the cycle of what we call digital reality, and we believe that this can bring an important piece to the table for an overall assurance of trustworthy AI, in such a sense that we have one part of the AI that supports for the increasing sophistication of automation, that where we have, say, things like in highly automated driving, we have you know, the environment perception and the path planning, trajectory planning. We have prediction modules and all this. But there's another part of AI that helps creating this regulatory framework for confirming compliance, and here AI can help with this synthetic data, digital reality, to have to create the right data sets that help us validating. It can help us creating or selecting critical scenarios, corner cases. So both in a sense that we try to find them in a given scenario set, or we use AI to generate them from knowledge. And we can also it can also support the diagnosis in the end, because we need to consider the fact that the term AI expert is also ambiguous these days. So we have AI experts, meaning the ones like the previous talker, who's really deep in AI, and all previous presenters, and who can actually contribute to making AI more robust and more trustworthy. And then there's a large number of people who are called AI experts, who are more in this like data scientist education type, who are applying AI frameworks, and we need to prepare for the situation that we have to create the proper tools in order to close this this gap. This gap of deep knowledge. Yeah, and I don't know if this will work. I can maybe show one video here. That is just one scene of ours where we created. Can you see that?
Yes, we can see it.
It's an intersection, obviously, but our algorithms created learned from data the styles of motion from pedestrians. So they are not handmade, they are not modeled by designers, but they actually learn from data, and they can apply various styles. They can also run. This video is recorded in slow motion. This is just one particular type of contribution for AI that can help creating a training and validation environment. There's many others, the general behavior of vulnerable road users, etc., etc. So for us, maybe if you ask for takeaway messages from me in this morning, this bifold view on AI is one of the most important ones, and the other one is the importance of uncertainty handling, as that is for me equally important as explainable AI. Yeah, I think that's exactly 15 minutes, right?
Yeah, that's cool. Thank you very much.
Yeah, good.
Thanks for sticking to a time slot. One thing, I think that we'll have to go after 11. I hope that you can all stay with us for Camille's presentation. I think that, yeah, I'm not a very good timekeeper because I don't like to interrupt people, especially when they give good, interesting presentations. So let's go, Francois, with your slides about what you do at CEA in this domain, and yeah, after that we will switch to the presentation from Camille. Maybe we will, yeah. You're on mute, Francois. I can unmute you.
Okay, it should be better.
Yeah, that works. We hear you. If you want, you can activate your video so we can see you, but you can do it like this.
But we'll try.
And from what I know from your presentation, I think that you should not be too long. So that's.
Yes, I should try to remain in the time. So you should see the screen in full screen. Is it okay?
Yeah, we see your screen. Go ahead.
Okay, so I start. So the idea is to give just an overview of the Trusted AI program launched at CEA. So first, some word. No. Okay. I lose the control, so I have to change the sharing. That this one.
Yeah, maybe you can just. Do you have animations?
Yes. Okay.
Okay. Good.
Okay. So just some word about CEA. CEA is a large research public center with 16,000 of people, several directions. So I will just focus on one direction, focused on economic competitiveness of industry. It means research applied for industrial transfer or for the results. And in these directions, there is 3 institutes. 2 of them are concerned by artificial intelligence, one related to micro and nanotechnologies, so it means microelectronics, and they are developing technology for microelectronics technology for embedded AI in particular, and one other on smart digital technology, which is more focused on system integrating software, and in particular for artificial intelligence. So we have the activity are organized around 3 aspects or 3 pillars. One related to applications, one other to tools and methods for the design, the verification, validation, and certification of artificial intelligence applications or artificial intelligence-based system. And the first one is on the deployment technology, including tooling, software, and hardware aspects. If we look on the various activity we have on these 3 pillars. There is a lot of things. I will not detail all of them. You will have a speech from Camille after on Pixano, which is one of these technology and tools, but there is a lot of other things related to artificial intelligence and also on trust. We have decided to tackle 3 challenges. One on the performance of the systems, which is quite mandatory for the application. One other on trust. It means that we have demand and solicitation for our partners that the application ensure and provides some level of trust, and it's more related there on methodology, design, algorithms, and certification process. And one other, which is related to frugality, both in terms of data, on use of a small set of data to reduce the cost of the learning and the energy cost of building artificial intelligence applications, but also for embedded systems, it's quite critical to have low power and low level of consumption of the implementations. And so this point is related really to the deployment of industrial artificial intelligence application. For this, we have launched an internal CA program related to trust and embedded systems. It has reflection of starting in 2017, and it's now launched. We have some internal roadmaps. I give just the main elements. We have 3 aspects. One on fundamental aspects related to understanding what's happened in this kind of systems, providing some new or precise, abstract mathematical models of artificial intelligence system components, and in particular for machine learning, using these models to be able to improve and accelerate the design, interpretation of their behavior, and possibly we dream to find some solutions with also colleagues, researcher colleagues from academics, to build some solutions to predict in advance what will be the behavior of the systems. One other aspect is on implementation. So I already mentioned this point, with strong focus on performance and optimization of embedded architecture, and how to manage reliability and trust of the implementations when we optimize the code and the algorithms, which could be sometimes contradictory. And certification. So it's one also important point. It's in the DNA of CEA from its creations to tackle with very critical systems. And so we explore several approaches. In them, there are the integration of formal validation techniques, but not only, also more statistical and empirical approach to build some qualification process, and perhaps at the end to find some way to obtain dynamic certification of the system. So during the life of the system, if we evolved, how to maintain the certifications of these systems. Around this roadmap, we have also launched some activities with the artificial intelligence community, with the aim to mix, in fact, community coming from safety engineering of the systems and community coming from artificial intelligence engineering. So for this, we have launched 3 workshops in 3 main important international conferences. You have the list there. What is quite significant is that these workshops, from their first editions, already gather a lot of people. The maximum of people possible attending for the workshops authorized by the conference. So it's quite a success, but also it's underlined that it's really something which is perceived by the community as being a real challenge, a real problem where all the actors have to share information. And for this, we have also launched a group called AI Safety Landscape, with a focus to define and to explore what are the taxonomy, what are the meaning of the words in the different community, different applications, in order to favor and encourage the understanding and the exchange among all actors. You have the website on the slide. To support these actions, the French state has launched what is called Grand Défi. So it's actions for research and development activity, ambitious actions. And one of these is focused on trusted AI. It's a very large project with 45 million euros of budget, with a lot of partners. It's pushed by the main French industrial partners involved in artificial intelligence, with relations with research community, and also with bridge with two main communities in France. One is the Aniti communities. You had some presentation before in Toulouse, and one other is the Data IA communities, which is focused on Paris-Saclay area. These projects want to set up a complete tool suite for developing artificial intelligence-based systems with trust and with the capability to qualify or certify them as much as possible. So we start by managing the data. So how to manage, for example, bias in the data. After, how to design the components with trust as objective. How to characterize and verify these components to assess the trust we can have in them. And as a lot of these applications are mainly embedded applications, so we have also focused on how to optimize and monitor the trust inside embedded artificial intelligence components. So now, if we come back to CA main focus point, it's the two points I will mention there are just two of all the activity we have that could be used for presentation in this series of seminars for the next sessions, if Gaël agree. One is on frugality. There's a toolkit is called N2D2. Is focused on optimizing the neural network structures and implementations and generating the code for particular targets. So important is that we take in as input the configuration of the neural network coming from outside tools with the standard formats. We use also the data used for learning and test. And now we re-engineer the architecture of the system in order to examine where are the costs related to memory use, performance, and then energy consumptions, and so on, and find some heuristic and assistance to the user to be able to have a more compact and more efficient implementation of his neural networks without loss of performance and, if possible, of robustness, accuracy, and so on. And the second aspect is the capability to deploy these codes on several targets. And as you see here, we have a large culture for microelectronic systems, so we can have targets related to FPGA architecture, or for some dedicated chips, including artificial intelligence accelerator for deep neural networks, or even with new technology like spiking that could also bring with them new computation models that push the user to directly re-engineer and reconsider the way to build the neural network, integrating these computation models. So it's one aspect. The second one is related to trust and come back from the CA background on formal methods for trusted software. So we have developed a very large tool set called Pharmacy that is used for safety and cyber security analysis and assessment of software-based critical systems. There is a lot of partnerships. It's very node. It's an open source solution shared by various both academic and industrial partners. And what we have tried and succeed to do is to integrate this kind of technology, to use and apply this kind of technology for some partial validation of artificial intelligence components. So the 2/3 are related to deep neural networks validation using formal techniques. The first one is in fact focused on the case where the neural networks learns from data coming from a simulator. And in this case, we are in a very favorable situations because the simulator can act as a formal specification of the behavior we expect the neural network to have, and we can then compute some delta between the implementations and the specifications. The second one is also neural networks, but there we don't have exactly the same situations. It's an embedded neural networks for the detection of marine line break on the oil extraction platform offshore. And the idea there was to evaluate the robustness, in fact, so the correct operational domain of these neural networks. And the idea was to see if we can identify some input domain where we can assess that the neural network gives the good classification in output. And the third one is for symbolic artificial intelligence related to constraint solving. And there the challenge was to be able to demonstrate that we could embed this kind of technology. It means to have a formal specification of the constraints, a formal implementation of the solver, and a full demonstration, so proof of the correctness of the solver, correctness of the constraints base, and demonstrate that the final implementation in C code respects all the specifications of behavior of the solver. It's work we have done from some specific industrial activity. On the two others, there are some paper published, so you can get in contact with me. I will give you the contact with the team. And I have finished. So just to synthesize, at CA we are pushing the idea to develop both trust and frugality as key challenge to favor the dissemination of artificial intelligence technology in industrial applications. Thank you.
Thanks, Francois. So, well, I think that I was a bit optimistic on the number of talks we can fit. So I'm sorry about that, but I think that everybody had enough time to present some of what they do and some of their interesting ideas. To be nice, I suggest that we move to the presentation from Camille now, and I after our presentation, if if we can have a conversation about what we do, what we just discussed this morning. I have a sheet of paper full of potential questions, and there is a question from Boris here. So yeah, Camille,